Hi, this is Geometry, topic 2. In this topic, we'll look at parallel and perpendicular lines. The topic essential question is what properties are specific to parallel lines and perpendicular lines. So we'll see a lot of lines in this topic and see the relationship between parallel lines and perpendicular lines and any properties that come with it. So if you look at the topic overview, we only have 4 lessons: parallel lines, proving lines parallel, parallel lines and triangle angle sums, and slopes of parallel and perpendicular lines. It's a short topic. Topic vocabulary would be flow proof, so we'll learn another type of proof. If you look at lesson 1, it starts with parallel lines. In this lesson, we'll be able to determine the measures of the angles formed when parallel lines are intersected by a transversal. Let's start with explore and reasoning. The diagram shows 2 parallel lines cut by a transversal. What relationships among the measures of the angles do you see? Do you see any angles that might have relationship? So like, are they supplementary, complementary? Are they vertical angles? Are they congruent angles? Any kind of relationship do you see would be answers. So if you measure it with a protractor, can you figure out the exact angles of them? Yeah. So the measure of each angle would be either 58 or 122. That means each pair is either congruent or supplementary. So the vertical angles here, 1 and 3 are 122, 2 and 4 are 58. If you measure these angles as well, this is 58 and that's 122. And so 7 is also 122, 5 is 58. So what are some relationships you might describe? First of all, the measure of each angle is either 58 degrees or 122 degrees. So each pair of angles is either congruent or supplementary. What else? The angles that form linear pairs are supplements, and the vertical angles are congruent, right? Okay, that was part A. Suppose a different transversal. So transversal is a line that goes through, it intersects. The transversal intersects the parallel lines. Suppose it's not this transversal, it's another transversal. Would you expect to find the same relationship with the measures of those angles? So what if you find 2 parallel lines? So this notation means the lines are parallel. And you should have arrows on both ends as well so that you draw a proper line. If you see a transversal like this, sorry, that's not straight, but it's supposed to be straight. Would you find the same angle relationships? Would you see the vertical angles that are the same? Yeah. What about supplementary angles, the linear pairs? They would be supplementary, and whatever the supplementary angle is, the vertical angle is also congruent. So the vertical angles would be congruent. What about the angles on the bottom? For parallel lines, you can find out by measuring the angles that Yeah, the angles that are corresponding, so they're on the corresponding side. Corresponding angles have the same measures. So you can say that you can expect them to have the same measures. So yes, the measures of the angles might change because the slope of the new transversal might be different, but the pairs of angles should still be congruent, supplementary, or both, right? We should still have supplementary angles and congruent angles because we got vertical angles as well. So the lesson essential question is that angle relationships are created when parallel lines are intersected by a transversal. So what are those relationships is what we're going to be talking about. Let's look at example 1. Identify angle pairs. Identify the pairs of angles of each angle type made by the snowmobile tracks. This is a snowmobile. It's a mobile, so it's a type of car that goes on the snow. So you see these angles that are formed. Snowmobiles go in a straight line. So you can see the angles formed by these parallel lines and the transversal here. You can label those angles with these numbers, 1, 2, 3, 4. 1 and 3 are vertical, 2 and 4 are vertical, 7, 5 are vertical, 6 and 8 are vertical angles. 5 and 1, they're called corresponding angles. They're on the same position on the transversal, right? So upper left is 5 and 1, so they're called corresponding angles. And then we got other angles as well. 8 and 4, they're corresponding. 7, 3 corresponding. 6 and 2, they're corresponding angles. Okay? What are alternate interior angles? Alternating. What does alternating mean? Alternating means you're going back and forth. So alternating angles are not on the same side. They're on the other side. So interior means it's inside. So if you have these two parallel lines and a transversal, outside would be here. Outside, outside. And then inside would be between the parallel lines. And so alternate interior angles are 7 and 1 and 6 and 4. They're the only alternate interior angles from this picture, okay? What about alternate exterior angles? Exterior means it's on the outside, right? So 2 would be corresponding angle with 6, but alternate exterior angles would be 8. It's on the other side of the exterior of the other positions, right? So 2 and 8 are alternate exterior, 5 and 3 are alternate exterior angles, okay? These are some key vocabularies that you need to know. Transversal, intersect parallel or non-parallel lines. The angle pairs are going to be called in these ways, okay? So let's look at try number 1. Which angle pairs include the named angle? So part A, angle 4. Which angle pairs include the named angle, right? So what kind of relationship can you find with the angle 4? And what about 7? So figure out any relationship you can make with these angles. And see if you can do it by yourself. Pause the video, Come back when you're ready for answers. Okay, are you ready? So what is the corresponding angle for 4? The same angle that is on the same position would be 8, the corresponding angle, right? So 4 and 8 are corresponding angles. Okay, and then what do we have? What about alternate angles? 4 is in the interior side, so you can have alternate interior angle with who? It's not on the same side, it's the other side. So 4 and 5, right? So 4 and 5 would be alternate interior angles. What else? Do we have another relationship with 4? What about same side interior angles? There is another relationship that you can have called same side interior angles. So you can say that 4 and 6 could be same side interior angles. Okay. What about angle 7? What is the corresponding angle for 7? 7 is here. So on the bottom right of your angle would be 3, right? So 7 and 3 are corresponding angles. And then 7 is on the exterior, right? So alternate exterior would be 7 and 1, angle 1, right? So 7 and 1 are alternate exterior angle. And you can have, what about same side interior angles? Same side would be 7, same side exterior. 7 and 2 would be same side exterior, but you don't have to write that for exterior angles. Or let's just write it, okay? 7 and 2 would be same side exterior angles. And 7 and 5 could be a linear pair. 3 and 2 could be a linear pair, and so on. Let's look at postulate 2-1. Same side interior angles postulate. So same side interior angles is a thing. There is a postulate about it. What is so special about them? Well, if a transversal intersects two parallel lines, then same side interior angles are supplementary. What does a supplementary angle do? Angles do, right? Supplementary angles add up to 180 degrees. So they're linear pairs. In other words, linear pairs. Okay? So same side interior angles are linear pairs. They add up to 180 degrees. So in this diagram, these two are parallel lines. You can look at these notation to see that they're parallel. And this is a transversal that goes through the two parallel lines. And so the same side interior angles 1 and 2 add up to 180 degrees. Okay? Remember that, and let's use that in the future. Let's look at example 2. Explore angle relationships. How can you express each of the numbered angles in terms of x? So we're gonna write expressions using x. What are the relationships that we can find? Angle 7 and x would be vertical angles. What do you know about vertical angles? they have the same measurement. So x is equal to whatever x is equal to. Angle 7 would be would have the same measurement as x. Angle 6 would have the same measurement as 8, right? But you know that same side interior angles are supplementary. So x plus 8 is 180, right? So 180 minus x could be your angle 8. And yeah, so the expression that you can write for 7 would be x. That could be x. 8 would be 180 minus x, and then 6 could be 180 minus x as well, because they're they're supplementary because they're on the same line. They make a line and they're vertical, right? So the corresponding angles have the same measures, right? So 2 and 4 would also have 180 minus x. 1 and 3 would also be x. Okay? So let's look at try number 2. If angle 4 is 118, what is the measure of each of the other angles? If this is 118, could you figure out the other angles using the angle relationship? Stop the video, come back when you're ready for answers. Okay, are you ready? So 2 is a vertical angle, so it would also be 118. Corresponding angles have the same angle measure, so all the angles that are the red, that are colored red, would have 118. Or what about the blues? By the linear pairs theorem and also same side interior angle theorem, they're supplementary, right? The blues are supplementary to the reds. So 180 minus 118 would give you 62. So the blues would all be 62. Okay, got that correct? Good job. Let's look at theorem number 2-1, alternate interior angles theorem. What about alternating interior angles? We know that same side interior angles are going to be supplementary. What about alternating interior angles? If a transversal intersects two parallel lines, then alternating interior angles are congruent. Because same side interior angles would be supplementary, there's only one angle measurement that would also be supplementary to this angle that is also supplementary to that angle, which means they're going to be equal, right? So 1 and 2 in this diagram are interior angles and alternating interior angles, and they will be congruent. They have the same measurement. And theorem 2-2, corresponding angle theorem. Corresponding angles are also congruent. Alternate interior angles theorem says that alternating exterior angles are also congruent. But what do you have to know? You need to satisfy the hypothesis statement if, only if, you have a transversal that goes through two parallel lines. What if the lines are not parallel and you don't have enough information to see that the lines are parallel? Then you cannot use this theorem. Okay, let's look at example 3 and prove the alternate interior angles theorem. Why are they congruent? Prove the alternate interior angles theorem. Okay, we're given M and N, lines M and N are parallel. We're going to prove that angles 1 and 2 are congruent. So the plan is that we're going to use the same side interior angles postulate because it's a postulate and we already have it, to show that angle 1 is supplementary to angle 3, and then we're going to show that angles 1 and 2 are congruent because they're both supplementary to the same angle, right? 2 and 3 are linear pairs. So 2 will be supplementary to 3, and because they're supplementary to the same angle, they must be the same. So we're going to start our proof with a given statement. Line M is parallel to N. You can use this parallel notation. And then we're going to say angles 1 and 3 are supplementary by the same side interior angles postulate. And then that means a measure of 1 plus 3 would be 180 by definition of supplementary angles. But you also have that the measure of angle 2 plus 3 would also be 180 because of angle addition postulate of linear pairs, right? And so you can say that angles 1 plus 3 is equal to angles 2 plus 3 because they're both equal to 180. You can either say substitution property or transitive property of equality. Then you can solve the equation, simplify, subtract measure of angle 3 on both sides, and you get measure of angle 1 is equal to measure of angle 2. That means the angles are congruent. Okay, so try number 3. Prove the corresponding angles theorem using a similar proof and approach. Okay, so if you can do it by yourself, come back when you're ready for answers. Okay, are you ready? All right. It doesn't have to be 2 columns proof. You can do a paragraph proof, right? You learned both of them. Whoops. Okay, but you can say that you can start with given statement. Lines M and N are parallel, and what else? This statement, and this is reasons. And then by the angle addition postulate, you can say that measure of angle 1 plus measure of angle 3 is equal to 180. And then what do? You're going to use the same side interior angles postulate to say that 2 and 3 will also add up to 180 because they're supplementary. Same side interior angles postulate. Okay, and then we're gonna use the same steps, right? So measure of angle 1 plus measure of angle 3 is the same as measure of angle 2 plus measure of angle 3 by the transitive property. And then by subtraction property, you can say measure of angle 1 is equal to measure of angle 2. And so measure of angle 1 is congruent to angle 2. Right? That's subtraction property, and that's the definition of congruence. So it's actually the same kind of proof, but what have we proven here? 1 and 2 are corresponding angles. And so by using a similar, by using almost the same, approach and the steps, we could also prove that corresponding angles would be congruent as well because they're supplementary to the same angle. Okay, if you got that proof correct, good job. You got it. All right, example 4. We're going to use parallel lines to prove an angle relationship. So using the diagram, we can prove the angle relationship. We're given that AC, so segment AC and DF are parallel line segments. And BE is perpendicular to DF. And we're also given that angle AEB is congruent to angle CEB. So this is a perpendicular bisector of DF. Does that make sense? Because it's perpendicular, and also it bisects these. Well, right now we can't really say perpendicular bisector yet because we don't know the relationship between these two transversals, but it does bisect the angle that is formed by these two transversals. Okay, now we're going to prove that BAE is congruent to BCE. So we're not proving any theorems now. We're just proving an angle relationship. It's a question, okay? We're proving using all the theorems and postulates we learned. So start with the given statement that these are parallel and that's perpendicular. And because we know they're perpendicular, it's going to be 90 degrees, right? They're right angles. So it's right angle here, it's right angle here, right? So BEF, BED, they're 90 degrees, right? By definition, the measure of them are 90 degrees. And then by angle addition postulate, AED plus AEB would be 90. And then CEF and CEB would add up to 90 as well. But we know that AEB and CEB are congruent, right? So if we subtract 180 minus congruent angle, they must also be congruent because there's only one measure that satisfies the equation of this, right? Angle addition equation. So we can say by the transitive property of congruence, angle BAE is congruent to angle BCE. Oh wait, did I skip steps? Right. And so by congruent complements theorem, AED is congruent to CEF, and then we can say that alternate interior angles are the same. So this transversal, looking at this transversal, alternate interior angles are these two, right? So these two are the same. You see that? And then these two are the same. And these four angles are the same measurement. So you can say that these two, by transitive property, are the same. And they're congruent. Okay, try number 4. Given that line segment AB is parallel to line segment CD, you'll prove that the angles 1 plus 2 plus 3 would equal to 180 degrees. It makes a triangle, right? The interior sum of the triangle would be 180 degrees. But how would you prove that using the given information? See if you can prove it by yourself. Come back when you're ready for an answer. Okay, are you ready? So, how do we start? We want to make sure that the sum of these three angles add up to 180 degrees. But how do we know? First of all, we know that these two are right angles, right? They're perpendicular. And so the other side of that, 3 plus 4 is also 90 degrees. And 1 is a 90 degree angle as well, right? So 1 plus ACD is 180 degrees by the same side interior angles postulate, right? So let's first state that out. Measure of angle 1 plus measure of angle ACD is 180 degrees by same side interior angles postulate. And then ACD is equal to 3 plus 4, right? Measure of angle 3 plus 4. You know that measure of angle ACD is equal to measure of angle 3 plus measure of angle 4 by the diagram. And you can say this is by the angle addition postulate. And so because you have these two equations, you can substitute 3 and 4 in there and say measure of angle 1 plus measure of angle 3 plus measure of angle 4 is 180 degrees by substitution, right? And then substitution property. And then you can say that 2 and 4 are congruent because they're alternate interior angles. That's a transversal that that touches those two parallel lines, right? So you can say, so first, simply state that measure of angle 2 is equal to measure of angle 4 by alternate interior angles theorem. And so by substitution, again, you can say that measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to 180 degrees. And now you have proven what you needed to prove. Alright, yeah, it does look a little bit confusing at first because you don't know which theorem you want to use, but try to look at the given information and get some hints from there and start from there. Okay? Let's look at example 5. 5 angle measures. The white trim shown for the wall of a barn should be constructed so that AC is parallel to EG, and so these two are parallel, and JA is parallel to HB, so these two are parallel, and JC is parallel to KG. Okay, 1, 2, 3, 1, 2, 3. What should measure of angle 1 and 3 be? So, can you identify any transversals that go through two parallel lines that could possibly relate angles 1 and 3? So first, you're going to look for relationships among the angles. So if you look at this diagram, you see that angle A is 68 degrees. And because these two lines are parallel, you know that the transversal, if that's a transversal, you know that angle 2 and EFB would be congruent by the alternate interior angles theorem, right? And you know that same side, if these two lines are parallel, you know that 1 and this angle, EFB, should be, they're on the same side interior angle. So what's the relationship of same side interior angles? They are supplementary. So 2 is congruent to this F. F is supplementary to 1. So 1 is also supplementary to 2 as well, because these two angles are congruent. Does that make sense? And 1, because EA and because these two lines are parallel, 1 and 68, they are same side interior angles, so they're supplementary to each other as well. That means these two angles must be congruent because they're both supplementary to the same angle 1. So guess what? This is also 68, and 2 is 68 as well. So what do you know? What would measure of angle 1 and 3 be? Well, you know that 1 is supplementary to 68, so 180 minus 68 would be 112. And you know that 2 is 68 as well. What is the relationship between 2 and 3? They are corresponding angles. If you look at these two parallel lines and that as a transversal, you see that 2 and 3 are corresponding angles. And so 2 and 3 have the same measurement. 3 is also 68 degrees. Okay? So this is kind of like a puzzle. It's fun. Let's look at try number 5. If measure of angle EJF F is 56, find the angle. Let's change our color. And if this is 56, find FHK. Find this one. See if you can figure it out by yourself. Come back when you're ready for answers. Okay, are you ready? Yeah, what are the relationships that you see? If these two are parallel, EJF. So that's talking about this angle, right? Not the whole angle over here. So what could be the parallel lines that we could use? Let's look at JC and KD, right? So they should be parallel, right? They should be parallel. So the transversal here says that, so if we look at these two, AJ and BH as parallel lines, and this JC as a transversal, then we can say that BFC is a corresponding angle and it will also be 56, right? And vertical angles are congruent, so that's 56. And 56 and the angle that we're trying to get, FHK, are same side interior angles. What is the relationship of the same side interior angles? They're supplementary. So 56 should be subtracted by 180 to get 124 for a measure of angle FHK. So the answer is 124. Got that correct? Good job. All right, let's summarize our lesson. What did we learn in this lesson? We learned a lot of postulates about parallel lines and angle pairs. So remember that we have a postulate, same side interior angles postulate, that says same side interior angles are supplementary. Other than that, all these theorem says that these angles are congruent. Which angles are congruent? Alternate interior angles, they're congruent. Corresponding angles, they're congruent. Alternate exterior angles theorem, they're congruent. Okay? So if you see these angle relationships, you can figure out some missing information for the missing angles. All right, guys. That was lesson 2-1, parallel lines. If you have any more questions, please feel free to ask Ms. Kim in class. Otherwise, we'll continue with the next lesson, lesson 2, proving lines parallel, in the next video. Thanks. Bye.